Morning. Yesterday, actually, we have studied about the characteristics of the wastewater. There we have discussed about physical characteristics, chemical and biological characteristics. Then in the chemical characteristics, actually, we have discussed about the solids and then like estimation of the organic matter in terms of like direct method and indirect method. And then today we'll see the that indirect method of estimating the organic matter present in the wastewater. Okay, then yesterday I started with the concept of BOD. Uh, BOD is the like biochemical oxygen demand. Okay, then it is the amount of oxygen required for microorganisms to degrade the biodegradable portion of organic matter present in the wastewater. Okay, we can estimate the BOD in the laboratory. Okay, just following a certain procedure. That before just estimating the BOD, we should know about some concepts like what is dilution water, why it is important. Okay, then we will see how to estimate the BOD in the laboratory. Okay, then generally in the laboratory, we are estimating the BOD in terms of like oxygen equivalence of organic matter oxidized, or we are measuring in terms of oxygen consumption. Okay, that means we are just this is the BOD bottle. Generally, BOD bottle is 300 ml capacity. Is it visible my screen? What about my screen, students?
Visible, ma'am.
Yeah, this is BOD bottle. BOD bottle is 300 ml capacity. Okay, because we have to estimate how much amount of oxygen is consumed for a particular period of time. Okay, for example, if you are taking 300 ml wastewater in this, then keeping it in this, keeping this BOD bottle in BOD incubator at a 20-degree temperature. Initially, the average temperature may be 20 degree. That's why they have estimated the BOD of the sample, the oxygen consumption, okay, by the microorganisms with a temperature of 20 degrees Celsius. They have just kept this bottle in the incubator at 20 degrees Celsius for 5 days. The reason for 5 days is okay that they proved that okay most of the carbonaceous organic matter may be converted into carbon dioxide during the 5 days of incubation. Then once that carbonaceous matters are oxidized, then the nitrosomonas and nitrobacter, okay, these bacteria act on the nitrogenous organic matter and converts the like ammonia to nitrite, nitrite to nitrate. Okay, that is called nitrification. Okay, we are just estimating the CBOD because CBOD is contributing almost 65 to 70 percentage of ultimate BOD. Okay, most of the contribution is from CBOD. Therefore, we are just estimating what is the CBOD in the laboratory. Okay, is it clear? Maybe you can see this curve. Okay, initially like there is a one like one that is called phase 1. Then this is the phase 2. The phase 2 is the oxygen demand for nitrogenous organic matter. The first one, okay, that is the oxygen demand for carbonaceous organic matter. Therefore, complete degradation of organic matter, like complete conversion of organic matter, maybe takes almost 20 to 25 days. Okay, but generally we used to say like infinitive days. We don't know how much time it will take for complete degradation. We are just bothering about the how much amount of carbonaceous BOD is present in the water sample or in the wastewater sample. Okay, now for example, if you are taking 300 ml wastewater in the BOD bottle, the wastewater contains bacteria. Then we are keeping this one in the incubator at 20-degree temperature for 5 days. The initial DO of this wastewater, generally the DO of the wastewater is less than 4. If it is the freshly originated, okay, if it is originated recently, we can say it may contain some amount of DO. If it is a septic sewage, it is that means if it may be if it is like maybe 1 week old or 2 weeks old, then you can see the color of the wastewater is dark in brown color, okay, then or black color. Then there will be no DO in that. Okay, that means the black color indicates that there is no dissolved oxygen in the wastewater. Then how do you estimate the BOD in that case? if you are just keeping the sample as such in the BOD bottle, somebody is giving the wastewater to you that you are taking directly 300 ml in the BOD bottle and then you are keeping it in the incubator. Initially, you are measuring some 4 DO. Okay, but after 5 days, it indicates 0. Then this will not give the valid BOD of that particular sample. Okay, the 0 represents, okay, that is not the whatever the procedure you have followed is not correct, because we need to provide some amount of oxygen in the sample for the degradation of organic matter, because BOD is measured in terms of oxygen consumption. Students, is it clear?
Yes, ma'am.
Yeah, that's why instead of taking 300 ml as a sewage or a wastewater, they are adding the dilution water. Therefore, the dilution water is, you should know what is dilution water. It is different from distilled water. Distilled water is for all experimental purposes, especially for the preparation of reagents. And we used to use the distilled water. It is free from minerals. All the minerals in the distilled water is 0 with a pH of like 7 or 7.2. Okay, but the dilution water is different. The dilution water is, it is a mixture of nutrients. Okay, mixture of nutrients like nitrogen and phosphorus, and then maybe sometimes, okay, if the wastewater is acidic in condition, acidic in nature, if it is from industrial sector, then you cannot, you may not see any bacterial species in that. Okay, because of the acidic conditions, it may not survive. Therefore, in that case, we have to add bacteria or seed, and then plus that water to be aerated. Okay, it is clear. Initially, you have to do the aeration. You have to take the distilled water, then keep this distilled water in the incubator at a 20-degree temperature before preparing the dilution water. Keep the distilled water in the incubator at a 20 degrees Celsius. Then after maybe 5 hours, that means the oxygen level will saturate corresponding to 20-degree temperature. Then we have to do the aeration with the help of aerator. Maybe you can use the fish aerator or any air compressor to aerate the distilled water. After aeration, add sufficient nutrients, nitrogen and phosphorus, because for microbial growth, the nutrients are very important. Therefore, we have to add the nutrients. You should not, you should not reverse this condition. For example, some people, what they used to do is like they will take distilled water, then add the nutrients, then they will do the aeration. Then in that case, you cannot reach the desired value of DO in the dilution water. Okay, once the salts are there in the distilled water, reaching the saturation dissolved oxygen content is very difficult. Therefore, what you have to do is take the distilled water, keep it in the incubator at a 20-degree temperature for maybe for 5 hours or 6 hours, then do the aeration, then add the nutrients required for the microorganisms. Okay, that is the standard procedure. We have to follow it for the preparation of dilution water. Once the dilution water is ready, then you have to take the appropriate amount of dilution water to the sample, wastewater sample. Okay. Anyway, I will just take somewhere here. Yeah. Once that dilution water is ready, then you have dilution water, then you have a sample, then with the proper proportion, then you just place like the mixed sample or diluted sample in the BOD bottle. Okay, I will teach okay how to just take the how to fix the volume of the sample later. Anyway, just now you see the procedure how to do the BOD experiment in the laboratory. Now the dilution water is ready. Then you have the wastewater sample with the proper proportion. Then you have to just fill the BOD bottle, that is 300 ml capacity. Maybe with you can have like 4 or 5 bottles. Okay, in order to see the consistency of the results, maybe you can have like 2 sets. Okay, then you just fill the all bottles with a sample. with the known volume, maybe 20 ml or 5 ml or whatever, maybe that we will see later. And then fill all the bottles with the 20 ml sample. Then the remaining is filled with the dilution water. Remaining maybe it is 280 ml. That is with the dilution water. Okay, I have fixed randomly. Okay, 20 ml sample, 280 ml is the dilution water. Now, immediately after just filling the BOD bottle with the sample and dilution water, discard 2 bottles, find out what will be the initial dissolved oxygen content. Okay, then you just note down that is 2 bottles are completely that is filled with the sample with the dilution water. I have just to discard it and find out the DO. DO at the initial DO of diluted sample. Of the diluted sample. That is at the day 0, okay, at time t equal to 0, you are just measuring what will be the value of the DO. Then keep the remaining bottles in the incubator at a 20-degree temperature for 5 days. Then at the end of 5th day, you just discard the sample from the incubator and find out what will be the DO after 5 days. Then note down the value. It may be, this may be like a D1, this may be D2. Now find out the BOD. That means BOD is the oxygen consumption, okay, during the 5 days of incubation period. Okay, or we can say that oxygen equivalent of organic matter oxidized. That is the BOD. Therefore, finding the difference, that is the initial DO. Initial DO minus final DO into dilution factor will give the amount of BOD exerted during the 5 days. Therefore, we are representing as 5,20. 5 represents the, you are just giving the incubation time as 5 days, okay, because you are calculating the amount of oxygen consumption during the 5 days period, and then that the incubation temperature is 20 degree. Therefore, finally, that should be multiplied with the dilution factor, because you are not taking the sample as such, you are just diluting your wastewater with the dilution water. Therefore, we have to find out the dilution factor. Therefore, dilution factor is volume of diluted sample. It is the ratio between volume of diluted sample by volume of the wastewater. Volume of diluted sample is always, because we are using 300 ml BOD bottle. Definitely the volume of diluted sample is always 300 if you are using 300 ml BOD bottle. Okay, this is 280 ml of dilution water plus 20 ml of the sample. Okay, therefore the total volume of diluted sample is 300. Then volume of wastewater is 20 ml. Okay, this is the dilution factor. Students, is it clear about dilution factor?
Yes, ma'am.
Yeah, then if you're not clear, please ask me. Okay, you should know what is dilution water, what is the sample. Okay, the sample is the wastewater. Diluted sample is dilution water plus the wastewater sample. Then use this formula BOD 5,20 formula to calculate the BOD 5. Okay, then that is the difference between initial DO and final DO, that should be multiplied with dilution factor. Now you have to see whether whatever the results you are getting as like no, it is a valid BOD results or not by checking 2 conditions. The 2 conditions are the final DO, the DO final, okay, should be greater than or should like 2 milligram per liter. Sorry, 1 milligram per Yeah, the final DO should be at least greater than or equal to 1 milligram per liter. And then the second condition is that DO depletion. DO depletion. That means the difference between DO initial minus DO final should be at least 2 milligram per liter. Should be greater than 2 milligram per liter. Is it clear? Students, is it clear? There are two conditions.
Yes.
Yeah, two conditions. The final DO should be greater than or equal to 1 milligram per liter. Then the second condition is the DO depletion. That is the difference between initial DO and final DO should be greater than or equal to 2 milligram per liter. Okay, if any one of the condition is not satisfied, then you have to discard the results. You have to check both the conditions to be satisfied to get the valid BOD results. Okay, this is very, very important. Therefore, the selection of dilution factor plays a major role to satisfy these two conditions. I have taken orbitally as 20 ml, but you should have some rough calculations before doing experiments, because it is not a single day experiment. You will not get the results immediately after an hour. Okay, you have to wait for 5 days. If it does not satisfy these conditions, then again we have to repeat our experiments. Therefore, the selection of the dilution factor is very, very important. Therefore, somebody gives a wastewater sample to you, you have to ask what will be the source, whether it is from municipal wastewater or from industries. Okay, therefore you have to ask specifically where it is from. Then you should read the literatures. Maybe you will get some idea about what will be the strength of the municipal wastewater in terms of BOD, or what will be the strength of the industrial wastewater. Okay, by reading the literature, you have some idea that okay, maybe the municipal wastewater means the BOD should be in the range of 200 to 300. Okay, industrial wastewater, then you have to ask specific questions like which industry. Okay, based on the literature, we can have some idea that okay, these wastewaters are with a BOD of this range. Okay, now you have to do some back calculation to fix the dilution factor. What I used to do in the laboratory is, okay, for example, for 50 students or 25 students, they used to have 5 batches. For each batch, I used to give different dilution factor. Before doing that, okay, we have to do some calculations. Okay, for example, the municipal wastewater or the wastewater from our campus, generally you have BOD in the range of 200 to 300 milligram per liter. Then, because we are preparing the dilution water in the laboratory, it is in our hand. It is complete control is in our hand regarding the preparation of dilution water. Therefore, you have to give importance to preparation of dilution water, like proper aeration, adding proper nutrients. Then definitely will get the dilution water DO. Dilution water DO may be around 8 to 8.5 milligram per liter. Generally, the tap water used to have DO of 8 to 8.5. Okay, then now we are preparing the dilution water with the help of distilled water. Therefore, by giving proper aeration with the aerator, and then we can definitely achieve the 8 to 8.5 milligram per liter of DO. That is from our side. Okay, then that is also one thing. Then second thing is, then we have the range from the literatures. Okay, with the help of this, maybe we can do a small calculation. For example, DO initial minus DO final, okay, into dilution factor is, you can have a 200. Then we have two criteria for this. One is that the final DO should be greater than 1 milligram per liter. Okay, then the DO difference should be greater than 2 milligram per liter. Okay, by considering the first criteria, the DO difference, that means the DO depletion, the difference between initial DO and final DO as 2 into dilution factor formula is 300 by X, because we don't know how much volume we have to take. Then you just equate with this What will be the X value here, students? Can you just tell me what is the X value?
Three.
It is 3, yeah?
Yes, ma'am.
Yeah, I'm doing wrongly. 3 ml. Okay. Then second thing is, because we are mixing the dilution with water with maybe some known volume of sample, it may come down to 8. Okay, we are making an assumption that it's like 8 minus the final DO should be more than 1. Therefore, you just assume it is 1 into 300 by X equal to 200. What is the X value here now?
Ten 10.5, ma'am.
10.5 ml. Okay. Then similarly, can you just do the calculations for other case with the 300 as a BOD? It is 2 ml, no?
2.
Yeah.
Yes, ma'am.
Then, yeah, second case. What will be
7.
the X? 7 ml. Okay. Now you have some ranges of the volume of the sample. It varies from 2 ml to 10 ml, or we can say like 12 ml. We can go with the 12 ml. Now in the laboratory, what you have to do is like you have to prepare now for each dilution. Maybe you can prepare with the 2 bottles. Okay. We have 2 ml, and then 4, 6, 8, 10, 12. Okay. Here 2 ml plus 298 ml dilution water, 4 ml plus 296, then 6 plus 294, 292, 290, then 288 ml. Is it clear? You have to have like now 2 bottles for each case. Got 1 and 2, 3 and 4, 5 and 6, 7 and 8, 9 and 10, 11 and 12. Now you have to, for measuring the DO at the end of 5th day, you need at least 12 BOD bottles. 12 BOD bottles. Then maybe you can additionally take 2 bottles to find out the initial DO. Because varying the volume of the wastewater with the because we are going only with very less volume of the wastewater, the major portion is the dilution water. Okay, therefore it will not affect the initial DO that much. Therefore, with any volume, like approximately you can take some 8 ml of 294 ml of dilution water plus 6 ml of the thing. Okay, or otherwise what you can do is one bottle you can discard at the point of initial time, and then find out the DO, and then remaining 1 bottle for each case you can keep it in the incubator and find out the final DO. Okay, therefore we should in order to check the consistency, that's why we are preparing two bottles for each case that should be placed inside the incubator for 5 days. Okay, now is it clear? Now you just prepare that you can make a table volume of the sample, and then you can note down what will be the initial DO. Initial DO will be same for almost all cases. Then final DO. Now after just finding the final DO at the end of 5th day, you have to do some small analysis. You have to go through the data. Okay, what are the things you have to check? You have to, for all the cases, the final DO should be greater than 1. For any one of the like volume of the sample, if it lies below like 1 milligram per liter, you have to discard that data. Similarly, the fourth column, you have to find out the DO depletion. That means you have to find out the difference between the initial DO and final DO. Then you have to check for the other criteria that the difference should be greater than 2 milligram per liter. If it fails, then you have to discard. For example, some of the volume, it may fall below less than 2 milligram per liter, then you have to discard. Maybe for 6 samples, okay, for a 6 like a different volume, then you are getting the, that means both the conditions are satisfied. Then you have to consider, you have to calculate what will be the BOD. That is the last column. The BOD 5,20 is initial DO minus final DO into dilution factor. For example, you have some values of 220, then 260, 280 or 221. Then just add all the valid BOD results and find out the average. Is it clear, students, how to estimate the BOD? Or how to select the dilution factor? This is very important. No, as an environmental engineer, okay, at least because you are studying environmental engineering too, it's full of with wastewater treatment. You should know about the BOD concept very clear. It is very, very important. Okay, because if your any wastewater treatment system should be designed based on the BOD, okay, of the incoming wastewater. Okay, therefore now you should know what is dilution water, why it is important in estimating the BOD. Okay, then how to select the sample volume for the estimation of BOD. Then two important conditions to get the valid BOD results. This is perfectly all right. This procedure is, you can just follow it without any compromising any of the things for municipal wastewater, because municipal wastewater contains lot of bacterial species. Also, whatever the distilled water we are preparing is completely free from organic matter. Okay, then because we are having lot of confidence what we are preparing in the laboratory. Okay, then the distilled water or the dilution water is free from organics. Therefore, there is no oxygen demand for dilution water. That's why we are not doing any blank. We are simply assuming that the blank correction as 0, because we didn't keep any like a dilution water bottle. No, without, in all the cases I have placed along with the sample only. Is it clear? I have not placed any of the BOD bottle, only with the dilution water. Even you can keep, but at the end of 5th day there will be no oxygen consumption. That implies that the dilution water is free from organics or free from organic matter. Therefore, there is no DO consumption, okay, during the 5 days of incubation time. Therefore, we are assuming that the blank correction is 0. Blank correction is 0. But we cannot follow the same procedure for the industrial wastewater. Sometimes that industrial wastewater is full of organic matter, but there is no microbial activities to act on that to degrade the organic matter. Therefore, what we have to do is we have to artificially add the seed or microorganisms or the active biosludge, okay, into the dilution water. In that case, we have to do the blank correction. Okay, is it clear, students? Why blank correction is important, especially if you are adding the seed or bacterial species into the dilution water. Okay, in that case, what you have to do is you have to prepare the seed, or directly you can take some sludges from the real treatment plant. Then you can add some quantity of seed or sludge, biosludge into the dilution water. Okay, now the dilution water is not only the distilled water with the nutrients, it should be added with the active sludge, okay, or active biosolids. Okay, you can see here. In that case, yeah, in addition to the sample bottle, that, okay, you can see here, yeah, this is the mixture of sample and dilution water. Here the dilution water should be filled with the seed, okay, because the wastewater is free from microorganisms. Therefore, we have to artificially add the seed into the dilution water. Now, they have kept for 2 bottles. The 2 bottles, okay, this is they have just in order to get the consistency, you can plan with n number of bottles, okay, according to your choice, how much amount of dilution water you have, accordingly you can plan the number of bottles. Otherwise, for the procedure here, just they have explained with 4 number of bottles. The 2 bottles are used for the measurement of initial DO, and then the 2 bottles are used for the measurement of the final DO. Here the dilution water is filled with the seed. Therefore, you should note down. Okay, you can see the color difference. Okay, one is with a sample with the dilution water that contains seed. Another one is only dilution water that contains seed. Okay, this is complete 300 ml is only with the dilution water. Okay, then here maybe 280 or 20 or 290 plus 10, that depends on the dilution factor. Okay, how you are selecting the dilution factor. Now immediately after filling the BOD bottle, then you just find out what will be the initial DO in the sample as well as the initial DO in the blank bottle. Okay, that means that contains the seed. And then similarly, just keep the 2 bottles in the incubator and find out what will be the DO consumption after the 5th day in the diluted sample, then DO consumption in the that is the dilution water alone. Okay, therefore you have to note down. Okay, this is B1, B2, another one is D1, D2. The D1, D2 is for the initial DO, then B1, B2 is B1 and D2, B2 and D2 is for the final DO. Okay, the previous case we have assumed that the blank is free from organics, therefore there is no DO consumption, therefore we have substituted D1 minus D2 as 0. D1 minus, that means the blank correction is 0. But here the dilution water contains the seed, that is completely organic in nature, that also demand oxygen during the 5 days of incubation period. Therefore, we have to consider like the DO consumption for the dilution water to calculate the BOD. Okay, now the formula says for BOD of like a seeded dilution water, BOD 5,20 is equal to like B1 minus B2, that is the DO initial minus DO final of the sample. Okay, then I think which term they are using it properly, I will see. Yeah, D1, not for blank, sorry. D1 minus D2, this is for diluted sample, minus, we have to subtract the blank correction. Okay, blank correction is B1 minus B2. This oxygen demand is for like completely for dilution water. Therefore, we have to use the term called F that I will explain later. What is F? F F into dilution factor. Dilution factor. Okay. BOD D1 as initial DO of diluted sample. Then D2 final DO of diluted sample. Then B1 is the initial DO of dilution water. Dilution water, it is mixed with the seed. And then B2 is the final DO of dilution water. This is mixed with the seed. Previous case, we have assumed B1 minus B2 as 0. Okay. But here we have to account this. Then that should be multiplied with a term called F. F is the it is a ratio between volume of seed in diluted sample to the volume of seed in control or blank. Okay, because you just remember that we have to do the blank correction. The blank correction is we have to find out, you just for 300 ml dilution water, this is the amount of DO depletion. For example, it is some values, you just 9 minus 8.2. Here we are not checking the criteria for dilution water. Dilution water we are not checking any criteria. Okay, only for the as a whole BOD we are checking the criteria. For the sample only we are checking the criteria. Initial DO on, sorry, the final DO should be greater than 1 and DO depletion should be greater than 2 milligram per liter. Okay, not for the blank. Then you just find out, okay, for 300 ml dilution water, okay, this is the DO depletion. Then for example, we are taking 270 ml dilution water in the sample, then it should be for 270 ml, what will be the DO consumption? If this, because the for example, you are taking like 270 ml, 270, some model calculation, 270 ml dilution water, 30 ml sample, 30 ml sample. Then other bottle you are taking completely 300 ml dilution water. Now we are finding the B1 and B2 corresponding to complete dilution water. Okay, what is the initial DO? What is the final DO for the dilution water with the seed? Now the difference B1 minus B2 is for 300. If the sample, like the bottle contains 300 ml dilution water, then actual the BOD bottle, like with the sample contains 270 ml dilution water. Therefore, we have to multiply with 270 in order to find out the blank correction. Okay, therefore, the factor F is volume of seed in diluted sample, seed in diluted sample to volume of sample, volume of seed in blank. Okay, this is the formula, we are using it to find out the F, or in terms of percentage also we can say percentage of seed in diluted sample to percentage of seed in control or blank. Okay, is it clear, students? Students? Yeah, I'm not getting any responses. Ayush, Ranjan.
Yes, ma'am.
Yeah, what are the two important criteria to be considered in BOD experiment?
Two important criteria.
To get the valid BOD result?
I can't remember, ma'am.
You can't remember. Then you are not attending the classes.
I was, but I can't remember.
Okay. Anyway, I will note down. Okay. Those who are not answering, then I will note down. Then,
okay,
yeah, Sridharan. Sridharan ST. Is not answering. Vineet Karthik Raja. Vineet. Sridharan is not there. Vineet. Vigneshwar, please note down that they are Vineet is not there. Sridharan is not there. Vigneshwar.
Okay. Okay, ma'am.
Yeah. Yeah, you can just note down. Batmashri. Batmashri. Thing you can note down Batmashri also. Sanjeev. Sanjeev. Okay, you can note down. Shubham, Aryan. Shubham, Aryan. Kritik Roshan.
Ma'am,
Yeah. Kritik Roshan. Yeah.
I think DO final should be greater than or equal to 1 milligram per liter. And DO depletion should be like DO initial minus DO final should be 2 milligram per liter.
Okay. Tuladar. Samit Tuladar.
Yes, ma'am.
Yeah. What is dilution water?
Ma'am, Beneath has some problem and camera. He has texted in the chat box.
Chat box. I will check. Yeah. Tuladar. Satyajit Patel.
Ma'am?
Yeah. What is dilution water?
Dilution water.
Yeah.
I think in some seeded, we have to seed the water. There is no dilution of water.
What is dilution water?
We have to seed it with some external factor like BOD.
No,
and,
seeding is different from dilution, no? Seeding is different. But dilution water is it with the distilled water or it is different from distilled water?
from distilled water.
Different from distilled water. What is the need for aeration to get the dilution water?
I can't remember.
Okay. Siddhant.
Yes, ma'am.
Yeah. Tell me, what is the need for aeration in dilution water? While preparing dilution water, we are giving aeration, no?
Yes, ma'am.
What is the need?
I don't know.
You don't know. Okay. Yeah. Tilak Srinivas.
Yes, ma'am.
Yeah. What is the need for aeration? For like preparation of dilution water?
Maybe to increase the concentration of.
To increase the concentration of?
The solution, ma'am.
Okay. Concentration of what? I don't know. People are not listening the class. Just they are switching on the like MS Teams and then you are moving here and there. You are not attending the classes. Okay. Tomorrow onwards, I will call any randomly 10 students. If they are not responding, I will assign 0 mark. Okay. I am accounting. Maybe I will increase the weightage of like answering part in the class, maybe with 20 marks or 25 marks. Okay, if you are not listening, if you are not attending the classes, then you may get 0 marks. Okay. You have to switch on your video during that answering part and then you have to answer it. One side teacher is teaching, then without listening, other side is, it is like completely with people are not there. They are not responding. You know? I will, from tomorrow onwards, it will be accounted. Vigneshwar, you can inform to the class that I will call randomly 10 students. I can have a list with me. Okay, then I will call randomly 10 students. If they are not answering, then they will get 0 marks.
Okay, ma'am.
Okay, in the course plan itself, I will include for this answering part. No, I am not expecting the answering part. That at least they should be there in the like other end. Okay, they have to at least listen the lecture. They should not think that they can see the video lectures. Okay, it is not the way, okay, of like attending the classes.
Okay, ma'am. I will inform.
Okay, please inform your classmates.
Okay.
Okay. Yeah. Purpose of doing aeration is because we have to satisfy two conditions. If the water is not sufficiently aerated, it is having sufficient dissolved oxygen, then not possible to meet out the two important criteria. Okay, therefore, like final DO should be greater than 1. If the strength of organic matter is more, if you're not having sufficient oxygen, maybe within 5 days itself, the DO comes to 0. Therefore, we will not get the valid BOD results. Therefore, in order to maintain sufficient DO for the 5 days of degradation, then we have to do the aeration for the dilution water. Please note down the problem. Okay, I have dictated now or explained with the two concepts. One is without seed. Seed means bacteria or active biosolids. Then how to find out the BOD 5,20. Then with the seed, then how to find out the BOD 5,20. Please note down the problem. Yeah, 5-day BOD test is performed. 5-day BOD test is performed on an unseeded primary effluent wastewater sample. Primary effluent wastewater sample. Full stop. 10 ml of primary effluent are added. 10 ml of primary effluent are added to each 300 ml BOD bottle. Each 300 ml BOD bottle, to which dilution water is added. Full stop. A total of 4 BOD bottles are used. In this particular test. In this particular test. The average DO concentration of diluted wastewater samples at the beginning and end of the BOD test is 9.2 milligram per liter and 4.3 milligram per liter respectively. Calculate the BOD 5 of the primary effluent. BOD 5 of the primary effluent. Then use the formula BOD 5,20. Before doing the calculation, you have to check with the two conditions. You have to see the final DO should be greater than 1. Here it is 4.3. Therefore, it is satisfying the first condition. The second condition, the DO depletion. That means the difference between final DO, initial DO and final DO should be greater than 2. Here it is more than 2 milligram per liter. Therefore, it is satisfying both the conditions. Definitely you will get the valid BOD results. That is 9.2 minus 4.3 into dilution factor. That is 9.2 minus 4.3 into, this is 300 ml BOD bottle. Therefore, 300 is the total volume of diluted sample divided by volume of sample is still. Okay, we'll get the BOD 5,20. What is the answer? I will ask. We need
147, ma'am.
147 milligram per liter. Okay. Then maybe you can note down this problem. Then we will see the answer tomorrow. This is with the seeded dilution water. They have prepared seeded dilution water. 20 ml of the secondary dechlorinated effluent is added to 300 ml bottle. That means the sample volume is 20 ml and then they have added to the 300 ml. That means BOD bottle. The remaining 280 ml is the dilution water. Then the average DO concentration of diluted wastewater sample at the beginning and end of the BOD test is 9.1 and 6.1. Then the average DO concentration in the blank containing the seeded dilution water at the beginning and end of the test is 9.2 and 7.2. Please note down. They have given 4 DO. One is for the diluted sample, like the first 2 values for the diluted sample. Then the last 2 readings are for corresponding to the seeded dilution water, 9.2 and 7.2. But the conditions you have to check it for the first 2 values, 9.1 and 6.1. That is for the sample. Okay, not for the blank. Then they have prepared the like a dilution water, like they have prepared 20 liters of dilution water that contains 40 ml of the seed material. 40 ml of the seed material. Now calculate the BOD5 of the secondary chlorinated effluent. Okay, the question is find out the BOD of the secondary chlorinated effluent that they have taken 20 ml. The remaining 280 ml is filled with the dilution water, but that dilution water they have prepared with the seed. For preparing the seed, they have taken 20 liters of dilution water. That means distilled water, nutrients, that is the after aeration, it is added with the nutrients. In addition to that, they have added 40 ml of the active biosolids to that. Okay, therefore from this you have to find out what will be the BOD5. That we will see tomorrow. I will stop with this.